When it comes to calculating limits, the main skill lies in the fact in understanding what property do you need to use. Can you use direct substitution? Direct substitution is just putting in numbers and calculating the result of the function. Or do you need to change the function? Do you need to use algebraic identities to change its form? Do you need to use strict formulas to maybe convert sine and cos into cot and tan, maybe? Or if the square root is involved, sometimes you might need to rationalize the problem. Let's just look at the examples. For example, for simple question 1, we have limit x tends to 5 and the given function is 2x squared minus 3x plus 4. Now, what property can we use here? To understand how to begin, it's always a good idea to put the value that is given as x tends to into the function. As in this case, if x tends to 5, you want to begin by putting 5 in the given function. In this case, it would become 2x squared, 5 squared is 25, minus 3 into 5, plus 4, which simplifies to 50 minus 15 plus 4, which is 39. So the answer we get here is not undefined. There is a concrete value for it. So in that case, if we get a concrete value, it means that this number, which here is 5, lies in the domain of f of x. So we plugged 5 into f of x, and then we got a finite value. As you can see, once we know that we can apply direct substitution, we'll separate out the limits with each individual term and carry out the limits for that, as in separating them from addition and then from multiplication, and remove and bring the constants outside, as in this case 2 was brought to the outside, 3 was brought to the front, and then calculate the limits. In this case, which is again just putting in the constant values, which gives us our answer. Next question. Next question involves limit x tends to 1, x squared minus 1, x minus 1 divided by x minus 1. Now again, to figure out how we're going to move forward, we should just put 1 in the domain of the function, which will again go ahead. When I do that, I'll actually get 1 minus 1, the whole thing, divided by 1 minus 1. Again, as you can see, this turns out to be 0 divided by 0, which basically does not make sense. So that is undefined. Well, when it is undefined, we can clearly say that the given value when it's undefined, we can say that this value does not lie in the domain of the function. When it does not exist in the domain of the function, we have to change the function in a specific way to give us a different formula, which will lead to at least some result for the limit. In this case, as we can see, x squared minus 1 is an algebraic identity, which we can change into x minus 1 into x plus 1, and there is obviously x minus 1 in the denominator. X minus 1 is the denominator and the numerator would cancel each other out, and then we'll be left with limit x tends to 1, x plus 1. Now again, we can just put 1 in the domain of the new function, which here is x plus 1. If I put 1 in this function, I get 1 plus 1, which is 2. So obviously it is not undefined. And thus we use number substitution for this part of the question. And that's how we get 2. Consider the next question. Again, I'll try to put 0 in the domain of the function. Just to think quickly, if it's always easier to put the number directly in the denominator, and the denominator turns out to be 0, it's pretty clear that the answer is undefined. As in this case, if I put 0 inside of t, if I put 0 inside of t, I get 0, and any number divided by 0 is undefined. So that part is clear that we will not be using direct substitution theory in this part of the question. So we need to further change the question to give a form where we can actually use substitution theory. In this case, we can always rationalize the function. On doing that, we get these terms where the 9 and 9 cancel each other out, the t square and t square will cancel each other out, and eventually we turn up with this term. Now, if you look carefully, we can actually substitute t in this term. As in, at this point, if I substitute t square with 0, my answer would just be 1 divided by square root of 0 plus 9 plus 3, which becomes 1 divided by 3 plus 3 and that gives us 1 divided by 6. Now, one important concept that comes up again and again is that when limit tends to 0, something happens with sine theta divided by theta, which the scenario is that sine theta divided by theta when limit tends to 0 is actually equal to 1. So if there is a sine theta in the question, maybe just consider it as a hint. Maybe you can use this entire identity to turn that form into 1. However, pay attention where you can use this identity sine theta divided by theta is equal to 1 only when the limit of theta tends to 0. You cannot use it for any other finite value or when it's undefined. Let's look at an example. Suppose this is our sample question. Limit x tends to 0, sine 7x divided by 4x. Now first of all, let's see if we can express the function differently in sine theta by theta form. In this case, our theta is actually 7x. So some way or the other, I need to bring 7x to the denominator. In this case, I can just multiply the denominator and the numerator by 7 and 7, and the form turns out to be like this. And do that, this entire part, which has been this part becomes 1, which, as you can see, limit x tends to 0 when the entire thing turns to 1 is 1. If this part is turned to 1, this entire thing again turns to 1. Again, this will all be down to 1, and our final answer would be 7 by 4.